Hi there, this is Nick Klosky, co-founder of Honeypoint 3D, and I welcome everybody to our July 2016 3D printing and 3D design webcast. We're using actually a new webinar kind of service this month, so I apologize if any of the emails or if any of the quality or any of this is kind of weird. We're kind of testing it out. So, but I see that, yeah, awesome. So, good. Yeah, I'm getting some comments and things in here. So if you have any questions, I really want to answer what you are wanting to know about. I certainly have things that I want to talk about, but I really want to reply to your questions. So I see that we have actually quite a number of people on the webcast this month, so that's great. There should be a little question box that you can put in your questions, and I would be happy to answer them. So I would very much encourage you to do that. Otherwise, I wanted to talk about a few things. So about 2 months ago, our book was published by Maker Media, and we kind of talk about this in all of our webinars. It's how to get started in 3D printing on Amazon. So I've never actually used the screen share. Oh, it's taking me to a thing. Hold on one second as I get this started here. Screen share. Oh, perfect. All right, screen one share. Kind of going off into infinity there. So if you do a search on Amazon for get started 3D printing, let's see, how to get started with 3D printing, under the books. Actually, I'm not entirely sure why our book is not showing up here. Or actually, I should probably use the tools that I think. So just go to honeypoint3d.com, and our book is right there. So if you click on the link, it takes you directly to our book on Amazon. And it's actually #1 in 3D printing books right now, and in the category above that, which is graphic design and all of that. So this is a great thing. It's looks like about $12 in physical form on Amazon. So if you just go to honeypoint3d.com, you can look at that. So let me figure out how to stop screen sharing here. Hold on one moment. So I apologize. This is kind of the first time that we're using this this software. So if anybody, oh, there we go. Stop sharing. Like that. Perfect. So if anybody has any questions, please ask them. Like this. All right, great. So what I wanted to talk to you today, besides the book and kind of talking about Honeypoint 3D a little bit, is some tips on Mesh Mixer. So as you know, on honeypoint3d.com, we have two sides of our business. One is 3D printing and 3D design education, and the other side of our business is rapid prototyping. So I am in charge of the education. So we will teach, and I'll get to your question in a second. We will teach people how to do 3D printing or 3D design, but then sometimes people don't have the time to do it themselves. So then we have a rapid prototyping division where we will do it for them. And so I got actually a question just going back, Reno, I guess. What is the name of your book? It's How to Get Started with 3D Printing. So if I go into screen share, actually, I could probably put it on this screen and share that one. If you go right here to honeypoint3d.com, which is just our homepage, you'll see it come up, and our book is right at the top right there. It's called Getting Started with 3D Printing, and it is published by Maker Media, so the people that put on the Maker Faire. So if you click right on that link right there, it takes you to the Amazon page for our book, like that. So just from our homepage, but that's it's very nice. So Maker Media puts out like how to get started with drones and Arduino and all sorts of things. So it's in a very good company there. So what I want to talk about today is we get a lot of requests from people who get 3D models that they find online from Thingiverse, or with a 3D scanning application that they have. Like 123D Catch or Autodesk Remake or something like that, and the 3D model isn't quite done or fixed. So I wanted to talk a little bit about how to do some model repairs that you would kind of see with models online, and kind of show you this. I'll be using Autodesk Mesh Mixer. So Mesh Mixer is free software from Autodesk, and that is one of our flagship courses on our website. A lot of training on Mesh Mixer, but then again, you don't have to purchase the training. You can just jump right into Mesh Mixer and start learning it. Mesh Mixer deals with meshes, so you're very welcome, Arino. Mesh Mixer deals with meshes, which is 3D models that have tens of thousands, hundreds of thousands, or millions of individual polygons. That's one side of the 3D printing and 3D design kind of world. The other side is something like Fusion 360, which is a parametric CAD software package. Those models are like what would be used to create like a cell phone or something like that. You wouldn't use Mesh Mixer really to create something like this. This is designed in a CAD program like Fusion 360. So our flagship course is on Mesh Mixer, and we're coming out with a brand new course on Fusion 360. I'm going to be finishing it this week and then putting the final touches on it and probably publishing that next week. So that's going to be very exciting because a lot of people are looking for the Fusion 360 class. But I want to show you a little bit about Mesh Mixer. So let me go in and share my screen here. Share this one. Great. So let me bring up Mesh Mixer like this, and I'll maximize it here. So let me import. So I 3D scanned a mouse. This is a Logitech mouse that I just have in one of my kind of desks right now. And this is a scan from our RTEC scanner. So this is a very, very detailed scan with textures on it, things like that. So I worked a bit on getting this up to date and nice. But the scan didn't really start out like this because I did the scan wrong. But this is something that I want to show you that you see a lot online. So I'm going to replace that with something that's a little bit more typical. So this is a mouse that a lot of it scanned, but a lot of it didn't, right? So Mesh Mixer can actually do the repair of this pretty easily. I want to kind of show how Mesh Mixer can do that. So first, if you go to Analysis to Inspector, that's kind of like the first thing you should start off with Mesh Mixer, and it shows all of the issues. Now, all of these pink dots are little tiny disconnected pieces. So if I zoom in right here, you can see that there's a piece right here. If I click on this little pink pin, that piece disappears. And if I click on this pink one, that disappears. So I may want those little pieces, but usually I don't. I can click Auto Repair up here, but I'm not going to. I'm just going to click on these pink ones to get rid of these little floating pieces. Because usually you don't need super tiny little pieces like this. So kind of click through those and click on that one like that. So now we have, a few more back here I didn't see. Got rid of those. So now we have some blue holes and some red holes. So the blue ones are contiguous areas that Mesh Mixer says it knows how to fix. So if we click on this blue hole, it actually filled it in really well. it assumed that there's things going upwards, and it actually created the mouse wheel. So that's awesome. So this blue hole right here, pretty easy, that one. But now we have a gigantic blue hole on the back. Let's click on this and see how it fixes it. Mesh Mixer will think about it for a second. And it did a pretty good job at filling that in. Now the red hole is a complex hole, which means that there are some jagged areas on this that Mesh Mixer doesn't really know how to fill in. And it's probably right because of right here, where the edge of the hole goes to another edge of the hole, and it doesn't really know what to do. So for something like that, we would go in and hit the select key and just kind of select that and delete it. We can also double click on these blue lines right here. I'm going to double click on this, and it's selected all the way around the edge. I'm going to hit the O key to optimize the selection, and then the B key, B is in boundary, and click accept. So what that does, see, it made a nice kind of smooth edge all the way across this. If I clear the selection, you can kind of see that it is smooth edge. I'm going to get rid of this little triangle right here. But now we can do some things that are very kind of easy in Mesh Mixer. If I go and try to fill in this entire thing, it's not going to fill in correctly. It's going to be very, very jagged and do kind of weird things. But I can kind of approximate it. What I can do is select one edge up here, select another edge up here, and go to edit to bridge and click accept. So that created a bridge from that one selection to another. And now what that allows me to do is, this is its own area. I can double click on this and put in the fill command, F for fill, and it fills it in. So a much smaller area. So that's kind of what I do when I work on fixing meshes, is I think, okay, the front of the mouse is going to be kind of the same. So I'm going to select here and select here and go to edit to bridge. Great. And then I'm going to select here and go to edit to bridge and accept that. So now that this area is defined, I'm going to go in here and go to edit to erase and fill and click accept like that. And so this side, that's a pretty easy hole right here. So I'm going to double click on that blue line, press F. That looks like a good fill, accept that. And this is a super jagged one, right? So I'll do the same thing. I'll go to this part and edit to bridge that. And now that this is contiguous, actually like that, and fill that. And then the same for this one right here. And sometimes if you press the F command and it doesn't work, you have to press the O command to optimize it. So that's generally the shape of the mouse. And all of these colors are just face groups. They're a way of selecting regions in your mesh. Now I'll go in with a smoothing tool and kind of turn on wireframe and kind of smooth all of these areas out, and kind of make them more homogeneous with the other parts of the mesh. And you can kind of see that these are all kind of evening out, becoming a bit more smooth. And remember this in the back where I did that fill command, I can hit that with the smooth command, robust smooth, and smooth that out a bit more. And I have a pretty, maybe turn up the strength a little bit. And I have a pretty good approximation of what this mouse looks like this. Let me go back and stop sharing and go back to the webinar. So that was very quick. That was about 5 minutes to take a really kind of awful scan with lots and lots of holes in it, and figure out how to repair it, and how to, I don't actually have the mouse here, but how to get it to something that would be really, really usable as a computer model for rapid prototyping or whatever. Now, one other thing that I want to talk about is if we go back into Mesh Mixer and I import the model that was really good, replace it with the nice mouse here. Oh, you can't see it because I need to share my screen. This one right here. Off into infinity. There we go. So if we see the mouse right here, this one has a texture applied. So this is the RTX scanners will create a texture, but the bottom of this isn't the best texture. If you look at this, it's kind of crunchy down here. And not the best thing. So Mesh Mixer will do a little bit of texture painting, but it turns all of this into a vertex color, which is sometimes good, but sometimes not as granular and nice as a texture map. If we look here, this is the mouse that was created by the RTX scanner. It's a patchwork of different textures, and you could go in with an image editor like GIMP or Photoshop or something like that, and just edit this image and make it, you know, nice. But it's sometimes hard to figure out where these things wrap over the mouse as you're going and editing, maybe around here next to the Logitech logo, and then you'd have to jump over here. That's a little bit more difficult. So one way to do this, I'm not going to do this fully, but one way to do this is Blender. So Blender I'm going to go to import the OBJ and go to my desktop here and import the mouse. So the mouse comes in like this without a texture, but you can go into texture paint, and here is the mouse, right, with the textures. And you can go down and use all sorts of painting tools. Let me turn up the thing on this. Press S for sample, so kind of copy the color there, and just start painting on the mouse like you would use in Photoshop as a clone tool. And I'm doing this, super duper roughly. But if you wanted to, maybe remove the Logitech logo, I could take a sample of the color right there and just start kind of painting this over. And there's lots of other tools inside of here for doing blurring, right? So you can sample some of these colors, color over this, and then blur this this patch to make it look like it blends in a little bit nicer. So I kind of went like this, and then you can click on this and do soften, smears, make this a little bit bigger, and start softening this. You see it's kind of blurring as I go over this logo. It's blurring it. Other tools, but then you can go and save this out, save this texture out, and use Blender as a way of kind of augmenting the textures that may not come in properly. Let me stop sharing and go back here. Great. Because we do get a lot of questions too about maybe 3D scans that people create with their cell phones, right? So that one of those products that's very easy is called 123D Catch. And it is either an app that goes on a cell phone or a desktop application, also 123D Catch, that allows you to use pictures that you take with your cell phone, 40, 50, 60, 70 pictures around an object, and turn that into a 3D model. That will create textures, but sometimes those textures aren't really the best. I'll actually show you. Let me show you one of this, because we did get a question earlier on this. There we go. And this is a product called Autodesk Remake. Once it comes up here. Get rid of Blender in the background. So Remake allows you to, let me maximize this. Remake allows you to create models with pictures. So let me, it'll kind of log in the background here. And once this comes up, I'll download a model that I created with Remake. I'll download that one right here of just the front door of my house, and kind of show you that you can create really nice 3D models with things like cell phones, but sometimes there are some problems with the textures. So this is downloading in the background. Autodesk Remake is very nice. There's a free version as well as a paid version that gives you, a little bit more granularity, a little bit more detail, things like that. And it's kind of downloading here in the background. Let me turn off Mesh Mixer in the background here. And in just a second or so, the front door will be downloaded. So I'll just give it a second here. This is by far the easiest way to come up with 3D models. You don't have to learn Mesh Mixer or Blender or Fusion 360. Just take pictures with your cell phone. And as you can see here, so this is almost done, 93, 96%, 99%, 100. So let's look at what this front door looks like. So it looks at it for a second, and then the front door will come up in a moment here. And some of these are actually pretty complex meshes, so it takes a little while to open. Mesh Mixer is actually faster to open these than Remake is, but we'll let Remake do its job right now after it optimizes for a second here, and here it is. So it's loading it, and this is my front door. So you can see this is pretty awesome. I wouldn't be able to model this by myself. A lot of little floating pieces and all that, but it's really cool. That's the front door to my house. But there were some trees that got in my way as I took pictures of the front door. So you can see here that though the leaves of that tree were actually imprinted on the texture of the door. So for something like this, you may want to go and redo the scan with those leaves not in the way. But maybe sometimes you only get one shot at something, and you might need to really just make this work. And so you could actually go and paint these textures on later using something like Blender. So I wanted to show you, a little bit on Remake as well. Usually I spend, if I don't get any questions, these webinars are about 25 minutes to half an hour, and we're right at the 25-minute mark. I would encourage any of the good number of people on this webinar to ask any questions that you might have about 3D printing, about 3D printers, about filament, the actual mechanical processes of printing, or 3D modeling, right? So, any of that stuff. I'll give you a couple minutes to ask a question in the little question box here. But if you don't come up with anything, that's great. You can always kind of think about this and look at the classes on our website. And if something pops into your head that I didn't explain properly in the classes, I'm more than happy to answer your questions here and then make the classes better for everybody else. Now, with that said, I am coming out with the Fusion 360 class probably next week, and I'll have a deal for our existing students for that that will discount it off of kind of the retail price. So look for that. We'll have a big announcement on that because we've been getting lots and lots of requests for Fusion training. So that's going to be good. I'm excited for it. It's going to be over 15 hours again of training, which is going to be similar to our Mesh Mixer class, where a huge chunk of that is going to be me going through 1 to 3 minute videos of every single thing inside of Fusion. So if you don't know what the sweep command does, it's just probably a 2-minute video that says, here are the components you need to do a sweep, and here's how you do it, and here are the results. Right, because a lot of times when I was learning Fusion, I just needed that. So, it looks like nobody has any questions. There was a statement from John that says the replay does not seem to be running, or is it just me? So this is a new platform, and so the emails, like I got an email last night at 11:30 at night that said, your webinar is starting now. Your replay is available now. Like, I have no idea why those went out. So I have a ticket into the webinar people to let me know why that happened. But okay, hopefully that'll be solved. So I do actually have a question. Yay, great. From George, how to deal with shrinking when we print with PLA. So this is a part that we talk about called design for manufacturing. There's a couple things about material properties when you print with them that you need to do kind of a prototyping process in how you design things. So PLA definitely does shrink. Also, how you print it can have effects on tolerances. So if you're talking about how to deal with shrinking, it probably means that you are dealing with something where the 1% or so of shrinkage is an issue, which means that parts are interfacing with other parts. When I deal with that, if parts are all printed at on the same machine with the same settings, and if everything shrinks at kind of a uniform way, then that kind of works. But that usually isn't how it works, right? You print one thing, and then an hour later or something, you print something else, and it doesn't really fit because maybe your air conditioning went on or whatever. Generally, what I talk about when I don't know if I usually have digital calipers near me at any given time. But if you're wanting to interface something, like I have these because I clean up a lot of prints. So this is a set of X-Acto knives, right? So if you're trying to create something that goes inside of this channel, this has very, very specific dimensions. And when you print something, when you 3D print something, it will maybe not fit because of the shrinkage that George is talking about. So I've generally seen that different brand lines of filament, like we have a filament called PLA++ from a company that it's kind of an impact enhanced PLA that's very good, from a company called Breathe 3D, Breathe 3DP. That has very low shrinkage, about 1%. So if I am printing with that, I will go into Mesh Mixer and use the units or scale to scale that up by 1% because I know it's going to shrink. Now, I have seen things on some other people's printers we've done consulting for, where shrinkage has only been in one dimension. So something may be properly sized in this direction, but shrunken in this direction. And that is usually a printer calibration issue where, one of the steps inside the firmware is a little bit off to get a certain things. So if you're getting something where things are shrunken in one dimension, it's probably a printer problem. But with just PLA shrinkage, I usually just build in about a 1% sort of thing. I also set my slicer. So a slicer is the program that turns a 3D model into the layers that are printed, right? So I can set some different things with that. In my slicer, I use Simplify 3D. You can say print from the outside in or the inside out for the perimeters. If I want a really accurate line, I will print the outside first going inwards, because I found that, as one layer is down and another one kind of lays over it, the outside edge is not as accurate when I'm printing from the inside out, where it does the inside layers first and then the outside last. I like to print the outside layers first. Now, obviously, if you're printing things with big overhangs, printing the outside layers first can cause some droopage issues. But generally, that's what I would deal with. Now, as with everything with 3D printing, it's a complex answer because, you want to aggressively cool PLA with fans. You don't want it hot. But, if you cool it too much while it's printing, the material will shrink more. That's one answer. Another answer is that your extrusion width might be off, right? You have a 0.4 millimeter nozzle on a lot of 3D printers, but the extrusion width is set in the slicer to be around 0.48 millimeters, right? So even though the nozzle is like this, when it comes out of the nozzle, it kind of expands a little bit. So that technically should be evaluated per material you're printing with. And it's not even just a PLA thing. Some PLAs will act differently than other PLAs. A good way to do that is to just extrude one line on your bed, or one or two lines, like building it upwards, and then measure what your actual extrusion width is. If your slicer thinks that you have 0.48 millimeters coming out, but your material actually spreads a little bit more, it expands when it comes out of your melting, your extruder, and it expands to 0.5 millimeters, you might not think that, 0.02 millimeters is a lot, but it actually can if things are interfacing. So I would do that extrusion test if you're really getting issues with shrinkage, to just test per material and per temperature, right? So a PLA might print at 185 degrees. It might also print at 210 degrees, and you really don't see much of a difference. But how it expands when it comes out of the nozzle may be very different at 210 degrees as it is at 185. So that is something that not a lot of people talk about, but it is certainly taken into account in your slicer, and your slicer bases everything off of that extrusion width. And if that is not, in jibe with what reality is, then that can cause some issues with tolerances. So I know it's a lot of information, but like with everything with 3D printing, especially in the consumer realm, it's just a lot of things can affect it. Things like, fancy machines like Stratasys machines and all of that are FDM machines, they control for a lot of those with temperature, enclosed chambers, all of that. But with consumer machines, a lot of those variables are just open. So I would guess, and then sometimes the extrusion with, I'm just kind of remembering the things that I've dealt with. The extrusion with, if you have a really home built machine, is something called the E steps per millimeter. So the number of steps for your extruder to get a millimeter out, if that's a little bit off, when you extrude 10 millimeters, when you tell your printer to extrude 10 millimeters, 11 might come out, right? So that would be called over extrusion. You can fix that in firmware, or you can fix that in your software by saying, you're in your slicer by saying, don't print at 100%, print at 99%, right? That will affect your extrusion width as well. But sometimes in some slicers, when you tell it to not extrude as much, it actually adjusts the extrusion width, so that doesn't get you much. So you might want to play around with that. But George said thanks. So hopefully in there is some sort of help or answer to that. Does anybody else have any questions out there? If not, then I'll wrap it up. I'll give you guys a few seconds to write in a question. And if not, I'm always I think I can chat as well. So Nick at, there we go. So that's my email address, Nick, N-I-C-K, at honeypoint3d.com. You can email me questions and stuff. For the students that are signed up for our classes, I just really want you to be successful. So if you have questions, let me know, and I will try to answer them. And if it turns into a super long question, then I might forward you to a class, or you can also buy some of my hours for consulting. But if it's an easy question or something where I can just kind of answer it, I'd be glad to do so. So I don't see anybody else with any other questions. So I really appreciate all of the people joining this webcast today, and I look forward to engaging with you and seeing what you print and what you design. So thank you so much, and have a great rest of your week. Bye-bye.